Okay, welcome back. We're going to talk a little bit about how you might want to organize your notebook this year. So I'm going to open a couple of documents here so that you can see what we're going to talk about. The first one is going to be as if you had a notebook page, just a sheet of paper. And I would not necessarily suggest copying everything that's in the Physics 2 notebook into your physical notebook. But one of the things you might want to do is as you go through, you're going to want to look at these objectives because the objectives are going to tell you what the tests and quizzes are going to look like. So one of the things we need to be able to do is you want to isolate what are we actually going to be questioned about. So if you look at over here on the unit learning objectives 1.1, it says I can construct representations of how properties are determined by the interactions of constituent substructures. Wow. Welcome to Sunday night. Okay, so when I hear that, now I've got to figure out what does that mean and how does that apply to what we're talking about now. So in this case, it's going to be, and we haven't taught this yet, but it's going to be the continuity model of fluids versus the particle model of fluids. And as we teach these things, you might want to make note of things like this. LO 1.1, be able to tell the difference and draw. Okay? So you might be able to come over here and here's one model and you've drawn some gas and this is gas. And then over here you've got something like this going on and you've got a different model. And so now you have the continuity, so this is your particle model, this is your continuity model, and you have tied that to Learning Objective 1.1. So how am I going to suggest that you organize your notebook to do that? Well, let's start like this. I'm going to suggest that when you get over here, you'll see that we have these big ideas. Okay? So you go to Big Idea 1, and on Big Idea 1, you're going to see several questions about what you need to know. And you'll notice that in the notebook over here on the left I've said in the first column record the date. So what I would suggest doing is you start with, we're going to do Big Idea 1, and it's going to be, you might want to label them 1.1, 1.2 and things like that. And I'll go down here to this first question. And so my date is 8/17/20. And I want to talk about a complete sentence of the idea with a drawing or a diagram. Third column is evidence, and give each idea a name. And so we're going to model that right now. So the first thing we're going to look at, and this is sort of an intro video. I'll be teaching this in class tomorrow, but this will also be the video for that. So we want to know, what does it mean when we say a fluid is continuous? Fluids are continuous. That's going to be a big part of how we interact with fluids in this section. So we're going to say fluids are continuous. And then, whoops, sorry, I got two mice going on. So fluids are continuous, and then the next column is where I'm going to draw pictures. Pictures, notes, examples will all go here. And then in this case, we're going to have evidence that shows this. So let me actually change this layout. Let's change the orientation to landscape. And I'm going to start over here real quick. So we want to create our notebooks so that we have our big idea. And I would write the question. So 1.1, the question that we have for 1.1, if I come over here and look, 1.1 is, how do you think particles of fluids are differently arranged than solids? So our big idea 1.1, and here we go, 8/17, how do particles in fluids work differently than solids? So I've made my notes, and all that's going to go on this page, the only thing I'm going to put on this page in my notes is literally answers to this question. And so my middle column will be my diagrams, my examples, and my drawings, sketches. And on the far right, I'm going to have evidence from lab, evidence from reading, evidence for this particular thing. So for example, let's say today I ask you, how do the particles in fluids, how are they different? How are gases and solids different from each other? How are liquids and solids different from each other? And so you might start with a sketch and you say, well, a solid looks like this. Let's say you've got a little solid, and this is your idea of what a solid looks like. And your idea of what a gas looks like is all these particles are just sort of scattered abroad. So you call this a solid, and you call this a gas. And then over here in this column, what are you going to do? Well, you're going to talk about what evidence do we have that a solid looks like this on the inside. You might say it doesn't compress. Solids do not compress. That is some physical evidence that argues that this object looks like this, and you might say gases are easily compressed. Okay? And so what you're going to do as you work through this idea, as we work through and get the different evidence, is you're going to answer each one of these questions that you see over here. These are your main big ideas, density and its properties. We want to be able to answer all 9 of these pages, or all 8 of these questions, the last question being the one that you would pick to work with. So as you go through, you're creating in your notes these sort of summaries and the evidence that goes with each piece as to not only what is the answer to the question, and then we get to the very bottom of the page, after we've taken all the notes and everything, whether that be front and back or just the front only, that's where you're going to put, at the very bottom, you'll put a line and you'll put your summary idea here, and that will be you draw all the evidence together, all the stuff together, and you give yourself a good, clean explanation of the answer. Okay? That's what we're going to work for. So after you've done this page, then you would go, I'm not going to save that, you would go and you make a page for the next piece. And in this case, these ideas, the pages you want to go with, are going to go with some of these questions. So the first idea is going to be states and matter. So we've got our questions over here. This is how we need to answer them. But our first real piece is going to be states of matter, object continuous, what does that mean? Density and its properties, and analyzing data and problem solving. So as we go through here, you want to create for each one of these ideas, each one of the 1A through 1D, a page in your notebook. So instead of doing a whole, you might not want to do a single page. The alternate form of doing that would be to do something like this. You could do 1A states of matter. And then your second notebook page would be 1B, models of matter. And then as you go through on each page that way, that would mean you'd only have 4 pages actually. So you'd have a states of matter page, object continuity, density and its properties, and analyzing data and problem solving. As you go through each one of those, you could put the questions from this section into page 1A, into page 1B, into page 1C. I think you will find that that will be a very helpful way for you to organize your thoughts and your ideas. If you don't need to change an idea, you just date and record everything that presents new information or a different way to look at it, all in that same location in your physical notebook. That when we go back through, we can look at, hey, what are all the big ideas for this particular unit, and you'll have a page that sort of is the summary for that total concept all in one location. I personally prefer 3-inch notebooks with 3-ring binders, and yes, 3 inches is probably a little too big for you, especially if you're carrying around every day, but you might want to get a couple of notebooks, or spiral notebook will be fine. Just make sure you leave yourself enough room. Okay, so there's our first video on how you might want to take notes. And then I will see you on the flip side where we actually teach our first bit of information. Hope you guys have a lovely evening, and I'll talk to you later.